Welcome back to the Foundry by Forge College. I am absolutely thrilled to have you back in our hands-on engineering lab today for this explainer. So if you were with us for the last lesson, you know we successfully built out the system machinery for our smart contracts, heavily focusing on feedback loops. But right now, we are stepping into a completely brand new phase. Today, we need to calibrate the actual tokenomics engine. Yep, it is finally time to take all that brilliant code we wrote and integrate it with real-world post-sale preparation. Okay, let's dive right into today's protocol. We'll be moving from code to tokenomics, checking out the 5 vesting dials, prompting AI for scenarios, running the simulator, validating the results, and wrapping up with preparing for post-sale.
Section 1, from code to tokenomics.
You see, getting your smart contract onto the blockchain, honestly, that was really only half the battle. Now I want to ask you this directly. We built the machine, but what numbers actually go in? Think about it. If we plug the wrong parameters into our perfectly coded vesting schedule, the token economy will quite literally explode on launch day. And trust me, nobody wants to be the engineer who accidentally dumps 100 million tokens into the circulating supply just because of a typo.
Let's look at how this builds on our previous work. Last time, we built the system machinery with those feedback loops. Basically, we built the engine itself. Today's focus is the actual tokenomics integration. This is where we sit in the driver's seat and physically calibrate the dials to achieve that crucial post-sale stability.
Which brings us to Section 2, the 5 vesting dials.
I want you to visualize a massive control panel right in front of you. Here are your 5 main dials. 1. Initial unlock percent. 2. Cliff in seconds. 3. Duration in seconds. 4. Beneficiary share. And 5. Revocable. Now keep in mind, these aren't just abstract variables sitting in your Solidity code. Every single slight turn of these dials translates directly into circulating supply and stakeholder incentives out there in the real world. But before we start cranking those dials, let's clearly define a really crucial term, vesting velocity. So what is it? It's the average daily rate at which locked tokens are released into your circulating supply. Essentially, your dials control the speed limit here. Turn them one way, and you've got this nice, slow, steady trickle. Turn them the other way, and you are dumping tokens onto the market at breakneck speed. And this brilliantly illustrates the trade-offs we face, right? A long cliff absolutely protects your early token supply, but it also concentrates a massive sell-off risk the exact moment that cliff ends. Conversely, a high initial unlock gives your community immediate liquidity, but it can trigger total price instability. Honestly, it's kind of like watering a thirsty houseplant with a high-pressure fire hydrant. Mastering these exact nuances is a huge part of the learning journey here at Forge College.
All right, moving to Section 3, prompting AI for scenarios. So we are going to generate some test parameters by bringing in a junior lab assistant, artificial intelligence. But here's the catch. If you just ask an AI to, make a token schedule, it gets way too creative and spits out unusable garbage. It needs deterministic, highly structured instructions. Step 1, provide the total token allocation. Step 2, define clear scenario goals. Step 3, demand strict JSON keys. And Step 4, you have to force machine-friendly units, meaning seconds instead of months, and absolute tokens instead of vague percentages.
The really crucial point here is getting an output exactly like this table. We asked our AI assistant to generate 3 distinct scenarios. First, a conservative launch. This has a tiny 5% unlock, a 30-day cliff, and a massive 720-day duration. Second, a liquidity-first approach with a hefty 25% unlock right up front and a much shorter 180-day duration. And finally, a refund-ready scenario, fully revocable from day 0. Just look at the stark differences here between the conservative approach and the liquidity-first approach.
On to Section 4, running the simulator.
Okay, this right here is the absolute climax of our explainer. We are taking the AI's raw JSON data and running it through a basic JavaScript simulator just to see what actually happens to our token supply. To do this properly, we establish critical evaluation windows. We check the initial unlock at day 0, perform an early check at day 7, a midterm check at day 30, and a long-term check at day 90. Doing this reveals the exact shape of our time series releases.
Now, what's really interesting about this slide is how visually striking the math becomes. When we graph the cumulative tokens at day 30, we instantly see if the AI's numbers align with our actual tokenomic goals. I mean, if that liquidity bar is towering over everything else, and our goal was supposed to be a conservative launch, well, we immediately know the AI's parameters are completely wrong and we need to go back and adjust our dials. Which naturally leads us to Section 5,
validating the results.
Because let's be real, we never ever blindly trust our junior AI assistant's numbers. We verify everything. There are 3 mandatory quality control checks we absolutely must perform to ensure our launch is safe from boundary errors. First, syntactic validity. Did the AI actually use seconds instead of days? Second, tokenomic impact. Do the releases match our 30-day goals? And third, edge case safety. What happens if the AI accidentally set the duration to 0? Does the contract break, or does it safely dump the tokens? We have to know for sure.
And this is exactly how you do it in practice. You create a strict pass-fail checklist. In this example, our initial release of 150,000 is well below our threshold of 300,000, so it passes. Our 30-day cumulative passes. Our 90-day average daily rate passes. But listen closely to this. If a metric fails, do not just tell the AI to quote-unquote fix it. That won't work. Iterate your prompt by changing exactly one variable at a time until the math works perfectly. Finally, Section 6, preparing for post-sale. So we've written the code, we've twisted the dials, generated the scenarios, and mathematically validated them. This meticulous validation is exactly what sets up your smart contract for survival in the real world. I really want you to burn this quote into your memory. Vesting parameters aren't vague promises, they are validated mathematical levers. When you take this kind of scientific approach, it completely changes how you communicate with legal teams, product managers, and community stakeholders. You aren't just guessing anymore. You have the hard math to back it up. So I'm going to leave you with this final, provocative challenge. Are your parameters refund ready? Think about it. What happens to these perfectly calibrated dials if a major investor requests a refund halfway through a vesting cliff? Well, that is exactly the complex reality we'll tackle in our next challenge on refund mechanisms. To dive deeper into these mechanics and learn way more about Web3 building, make sure you visit forge.college. There are incredibly comprehensive resources there to accelerate your journey. Thanks so much for joining me in the lab today, and I will see you in the next explainer.